Okay, so I'm going to go ahead and walk through a demo on the new group delay application on the N9482B UXA signal analyzer. I'll be using the new M9484C VXG vector signal generator as the source. And this application is great because it is all done from a single UI here on the UXA, and the UXA will take control of the VXG. So first we're going to go ahead and set our center frequency. I'm using a bandpass filter with a 650 megahertz wide bandpass and a center frequency of 10.8 gigahertz. Let's go ahead and go to the measurement setup, where we will first connect to our signal generator. As you can see here, I already put in the IP address and gave it a name, added it to the list, and then we'll go ahead and connect. Everything lights up green, letting me know that it is connected. Now I can go ahead and apply these initial settings to the signal generator, which would be the center frequency, the amplitude, turning the RF output on, and then letting it know to do this on channel 1. But first, we could just go ahead and take a look over here at the signal generator. I connected to it. You can see it says that the system is under remote control. Nothing is on. The center frequency is 1 gigahertz and there's no signal playing. Let's go ahead and apply these settings to the signal generator and then take a look. You can see now it's set the center frequency, the power to minus 10 dBm, and turn the RF output on. There's still no signal playing though. So to get something playing out of here, we're going to have to go ahead and set up our tones. And for this particular situation, I'm going to set up 1001 tones with a tone spacing of 1 megahertz. And it's saying that the tones need to be applied to the signal generator. But before you can do that, we'll go ahead and take a look at that. It wants you to apply your phase fill to the tone table first. So this is your tone table down here. And right now, your phases are random, but we're selecting a random phase with a fixed seed, and this is our seed, it's 0 here. And we go ahead and apply the tone fill to get our tone table filled in, and then apply the tones to the signal generator. And there you go. We could see that we're now getting flat tones out. There's a little bit of ripple in there. And if we go to the signal generator, you could see that a signal's playing. So what we'll do now, as you may have noticed, there is a button for do calibration. And right now we just have a through path in with the filter is not installed in the fixturing yet. So we'll go ahead and do the calibration to flatten out our plots there. Now the calibration is finished. And you can see that these are all perfectly flat across here now. So I'm going to take a second here to go ahead and put the filter in. I'm going to go ahead and restart the averaging with the filter in. And to see this here, what we'll do is we'll change this to 0.3 nanoseconds or 300 picoseconds. And you could see the shape of our filter here. You could see it as well in the spectrum. But you can see that there's a lot of ripple through here. I'm going to go ahead and set some markers up. We'll make this one a delta marker, and we're going to put it onto the group delay plot. We'll send marker 2 to the group delay plot as well. And then we'll put marker 1 up here at the peak. And we'll put marker 2 here in the valley. And we could see that we have about 1 nanosecond of delay through our device. But like I said, there's a lot of ripple in here. So a way to overcome that and smooth it out is to add in some attenuation. And this ripple is caused by reflections, either coming from the source, reflecting off of the filter back to the source, or reflecting off of the analyzer back to the source and filter. Okay, so now I have my attenuators installed in line in the fixturing. We're going to go ahead and restart our measurement here. And you can see the trace has smoothed out, but there's a little bit of rippling here on the edges. There's something you could do to help with that is to go over to your signal generator, and again, you can control everything from right here in the UI of the analyzer and increase the output power. Apply tones to the signal generator, and you can see that it's looking very smooth. There's less ripple in there, and everything's looking very good. And again, we have about a 1 nanosecond of delay through our filter here. If you'd like to see the video that this demo was inspired by, please check out Dr. Joel Dunsmore's YouTube page to find out more.